Okay, section 8.5, adding and subtracting rational expressions, key terms. We're also going to be dealing with complex fractions today as well. Complex fractions, a fraction within a fraction. A fraction where the numerator is a fraction and or the denominator is a fraction. We're not allowed to have complex fractions. You will learn how to remove and simplify the complex fractions. Okay, but that's what a complex fraction is. It's a fraction within a fraction. Okay. Lowest common denominator, it's least common multiple. It's what you have to find in order to be able to add or subtract fractions. And we're going to be adding and subtracting fractions, which means you need to get a common denominator. And the least common denominator is what you want, or lowest common denominator. Rational expressions must have the same denominator in order to add or subtract. Domain restrictions, we need to eliminate the variable values that result in the division by 0. We really talked about that a lot on Tuesday. It's still going to hold true today, but not nearly as strongly, but it's still something we need to pay attention to. And so our domain restrictions, like I said, can't have 0 in our denominator. So, problem number 1, find the least common multiple of each pair. So this is in preparation of sorts for being able to add or subtract fractions. Least common multiple, least common denominator, same thing. So this is more of an exercise to kind of get you thinking in the right direction. What we do here is not exactly the same thing we're going to be doing when we're doing the adding and subtracting fractions, but it gets it going in the right direction. So to help push us in that right direction, what I want to do is think of things as factors, because that's what we're going to be looking at. Is we're going to be looking at factors. So the factors of 4, and we want to do the prime factors of 4, are 2 and 2. 4 is 2 times 2. 10 is 2 times 5. Okay. Our least common multiple, our lowest common denominator, comes from the first thing we list is anything that is the same in both of them. I have a 2, and I have a 2 in each of my terms. So my least common multiple has to have a 2 to match that 1 that's in both of them. Okay. So I've taken care of this, and I've taken care of that one because they're a matched pair. Any matched pairs, I have one of those. Now, to get my least common multiple, what I need to do then from there on out is anything else that I haven't already crossed out or circled needs to be listed. So this 2 is taken care of. This one was not. I need to have that in there. This 2 is taken care of. This 5 was not. I need to have that in there. Okay, so I list what's shared. And then anything from either grouping that wasn't already taken care of by the shared ones. Multiply them out. 2 times 2 is 4 times 5 is 20. The least common multiple of 4 and 10 is 20. That's the smallest number that both 4 and 10 divide into. Is it the only one? No. There's 20, 40, 60, 80, 100, so on, so on, so on, so on, so on, so on. This is the smallest, which is what you want to have when you're doing your fractions, the smallest. Okay? 9 and 15, same idea. 3 times 3 for 9, 3 times 5 for the 15. What do they have in common? They each have a 3. So I have a 3. And that one's gone and that one's gone. And then I take care of this 3 here, and I take care of that 5 there. 3 times 5 gives me 45. The smallest number, 9 and 15, will play into it. I have 2 9ths plus 4 15ths. 45 is going to be my common denominator. Okay, that's kind of what we're doing here. Okay. These ones here, it's fairly simple. I do the same thing that I just did for the 4 and 10 and 9 and 15 for the 2 and the 7. Okay, 2 and 7 are what we call relatively prime. They have no factors in common. So that means I list 2 times 7 because they have no factors. 2 doesn't go into 7. 7 doesn't go. There's nothing that goes into both of those numbers except for 1. It's relatively prime. Variables are a little different. Every variable I have has to be represented, and the highest power that's listed is my power of my variable. So that means I have to have x squared. Okay? So I have 2 times 7 times x squared, or 14x squared. And that's my least common multiple, 14x squared. On the next one, what do you think I have to do first? I have to factor. So I factor this quadratic, x minus 2, x plus 3. Do I have any factors in common? Yeah, I have x minus 2 and I have an x minus 2. So I have x minus 2 as one of my terms. So I took care of this one. I took care of that. What do I have left? X plus 3. Same thing here. You have to factor first. Pull out a 2, z minus 4. Okay, so what are my factors? Ooh, z minus 4. That takes care of this, takes care of that. What else do I have? I have a 2. Now, for purposes of, if we were actually combining 2 fractions together, for purposes of that, I would write it as 2 times z minus 4, just to put the 2 in the front to make it look pretty. I would not distribute. Okay? If we are going to do more things, you want to keep it in factored form. Okay? We might be able to, after we add or subtract fractions, reduce the fractions. If we're going to be able to reduce, we're going to need it in factored form to reduce. Always leave your denominators in factored form. Always leave them in factored form. Okay? So the next one's actually pretty easy because y plus 3 squared, remember, is just y plus 3 times y plus 3. So I take care of my shared y plus 3. That's that one and that. So I get y plus 3. And then anything else I haven't already used, I need to use. The 2 from here, the 3 from here, and then the extra y plus 3 from that one I didn't use. Now, I would do this, make this 6 times y plus 3. And I would go ahead and write that as y plus 3 squared. But if you want to leave that as y plus 3 times y plus 3, that is also very good. But do multiply the 2 with 6. Okay. Questions about this? Okay, your turn. Do those. Here we go. Let's do these. So once again, 3 and 5 are relatively prime. So least common multiple between 3 and 5 is 15. That's easy. 6 and 8. 6 is 2 times 3. 8 is 2 times 2 times 2. This one is shared, so I have a 2 from that. And then I have a 3 and another 2 and another 2. Times 3 times 2 times 2. Or 24. And hopefully you saw that it's 20. You know that the least common multiple of 6 and 8 is 24 anyways, and can figure it out by other methods. I'm okay with that. I'm doing the factoring to make the connection to what we're doing with the algebraic stuff. That's why I'm doing the factoring, okay? If you get, oh, I know what it is, it's 24. If you got that, great, fantastic, I love it. But I'm doing it this way to make the connection to the other things we're doing, okay? 4 and 12, the least common multiple between 4 and 12 is 12. Because 4 goes into 12. 12 is the smallest thing 12 goes into. So I get 12. X and x cubed is x cubed. I have to factor this one. Y plus 5, y minus 4. My plus 5s, I have this plus 5 here and that plus 5 there, so it's y plus 5. And then I have the y minus 4 left over. Do not get comfortable thinking that it's always going to be the two factors of one takes care of the other. That won't always happen that way. Factor out of 3, a minus 3. That's my least common multiple for that. And then the last one, I have 5 and I have 6, 5 times 6. And then I have a y and I have 2 of them here. So I have y plus 2 squared. So 30 y plus 2 squared. Don't get real hung up on these, the least common multiples part. But the idea, I wanted to get you thinking in the right direction for finding common denominators. Okay? Things will be a little different when we get there. Good luck. So, add, subtract, simplify, and include domain restrictions. All right. So here's what we do when we're adding and subtracting fractions. I need to get a common denominator. I do this a little bit differently than we just got done doing. Okay, so I look at the first set of fractions and I go, okay, what is in this denominator, the denominator of my second fraction, that's not in this denominator? What's here that's not here? Y. That means I have to put a y in here. If I have to, how do I get a y in here? I multiply times y. And if I multiply the denominator, I must multiply the numerator. So this fraction now becomes negative 7y squared over 3xy. And then I do the same thing in reverse. What's in this denominator, the first one, that's not in the second? 3. So I have to multiply by 3 and by 3. So I get plus 12x squared over 3xy. I now have a common denominator, 3xy, and I just add my numerators. Negative 7y plus 12x squared. Can I combine negative 7y squared and 12x squared? No, they're not like terms. The only thing I'm going to do is rearrange them, 12x squared minus 7y squared, to make it look pretty. Because we like things that look pretty, don't we? Flowers, puppies, kittens. Right? Things that are cute and pretty we like. Okay? What can't our denominator be? What are our restrictions? X and y cannot be 0. So in the second example, we'll move it up a little bit here. What are our domain restrictions on this? What's our domain restrictions on this? X can't be negative 2, and X can't be 1. So X cannot be 1 and negative 2. Even after adding and subtracting, our domain restrictions are not going to change. Okay, so I'm done with that. This is a little more difficult as far as my common denominators go, but it's still not that bad. Here's the question. What is in this denominator that is not in that denominator? What's here in the second fraction that's not in the first one? Remember, it's things that are multiplied, not things that are added or subtracted. Remember when we are reducing it the other day? It's things that are multiplied. So we have to think of these as factors. And I knew you guys were going to say negative 1, but it's not. It's x minus 1. Because remember, we're talking about things that are multiplied. X minus 1 is not being multiplied. That's x minus 1. That's subtraction. So I have to think of x minus 1 as an entire factor. Remember, think about quadratics. Think about polynomials. X minus 1 is my factor. So what do I have in the second denominator and I have in the first? I don't have x minus 1. So I have to multiply the numerator and the denominator by x minus 1, which for this fraction, 5 times x minus 1 gives me 5x minus 5 all over x minus 1 times x plus 2. Do not FOIL out the denominator. Leave it. One, you don't want to make a mistake. 2, if we can reduce later, you'll want it in factored form anyways. Minus. What is in the first denominator that is not in the second denominator? X plus 2, which means I need to multiply by x plus 2 and x plus 2. So 3 times x plus 2 is 3x plus 6 all over x minus 1, x plus 2. And here's the really nice thing I like about adding and subtracting fractions. I already know what my denominator is going to be because I already have a common denominator. My denominator is going to be x minus 1, x plus 2. Bless you. Now I combine up like terms in my numerator. And here's the thing you have to remember. What do I have going on here? I've got subtraction. Easy thing to do. There's a couple ways to do this. The easiest way to do that is to change your subtraction to addition. Make that positive, and then change the sign of everything in the numerator. Okay. 5x minus 3x, 2x. Negative 5 plus negative 6, negative 11. And here's an important question to ask. Can I reduce? My denominator's factored. Neither one of those factors match my numerator, but can I factor my numerator? Is it possible? What can I factor in my numerator? I can't. I can pull a 2, but then I'd get 2 and 11.5. I would not get either one of these, so I'm done. But you always need to check. Can I reduce? You always need to check, can I reduce? Okay? And on the top of your next page is still more examples, right? B and C, or C and D, sorry. Right? Okay. I want to make sure before I flip to them, I started doing that. Okay. What do I need to do first? I need to factor my denominator. First one is, second one isn't. Second one, 2 numbers multiply, give me 2, give me negative 3. Ooh. C minus 2, C minus 1. That's my new denominator. And what are my domain restrictions now? Because we always factor before we do domain restrictions. What are they? C can't be 1 and 2. This is really nice. I like this problem. You know why I like this problem? Because I already have my common denominator figured out. Okay. What's in here that's not in there? C minus 1. So I need to multiply this one by C minus 1 and C minus 1, which gives me C minus 1 times C minus 2 in my denominator. I do have to FOIL out, for addition purposes, I have to FOIL out my numerator. So I have to do C plus 3 times C minus 1. I have to do that. C times C gives me C squared. And then I have 3C minus 1C, which means I have 2C. And then 3 times minus 1 is minus 3. Okay. And I have to FOIL that out. I don't like to do it, but I have to do it because I can't combine like terms if they're in factored form. My denominators leave factored. Okay. What is in this first denominator, my original first denominator, that's not in my second denominator? Nothing. Everything that's here is already here, so I don't have to change my second fraction. just copy it over. Minus 6c minus 7 over c minus 1, c minus 2. And now I combine up like terms. Okay. This is subtraction again. Make it addition. Just change the sign of everything in my numerator. Change it to addition. Sign of everything in the numerator. My denominator will not change. C minus 1, C minus 2, and I have C squared. 2C minus 6C minus 4C. Negative 3 plus 7 is plus 4. Okay. Now comes the fun part. He says sarcastic. I'll sort of see something. Can I factor my numerator? Two numbers that multiply to give me positive 4 that add to give me negative 4. Is it factorable? Yeah. Negative 2 and negative 2. So this factors into C minus 2 times C minus 2 over C minus 1 times C minus 2, which means I can reduce C minus 2 over C minus 1 is my final answer. Always, always, always try and reduce after you add or subtract. Sometimes you can, sometimes you can't. Okay, I don't know. We couldn't on the first two. We can on this one. You with me so far? Thoroughly confused yet? If you take your time, and like I said, factoring quadratics is key to doing this. If you can do your quadratics, this is a piece of cake. If you can't do quadratics, you're going to struggle. Okay, doing quadratics is key to this. So once again, my first step is to factor my denominator. And most likely, but not guaranteed, b plus 3 would be one of my factors. Would that work here? 3 times 5, 3 plus 5. Yeah. b plus 3, b plus 5. Is there anything in this first one that's not in the second one? Anything in this first denominator not in the second denominator? Well, in here that's not there. Yeah. No, there's nothing in the first one that's not in the second one. So this is my common denominator. What do I have to multiply the first fraction by? b plus 5. b plus 5. b plus 5. So I do the first fraction. Foil it out. If you need to do it out in the sidebar or something like that, feel free. Shortcut, right? Square the first terms. Add the two numbers, and that'll give you how many b's you have. 2 plus 5, that means I have 7b. And then you multiply the last two numbers. 2 times 5 gives me 10 over b plus 3, b plus 5, plus b minus 4 over b plus 3, b minus 5, b plus 5. And what did I forget to do? What are my domain restrictions? -3 and -5. -3. Okay. Question?
Is that b plus 5?
It's a b plus 5, and it's b plus 5. They're lousy. They're sloppy. I'm sorry, my bad. You should know how to read my hieroglyphics by now. Combine up like terms, and this is addition, so you just combine up like terms. b squared plus 8b minus, or sorry, plus 6 all over b plus 3, b plus 5. Okay. Now I want to look, can I factor and reduce? Let's take a look at this. Are there two numbers that multiply to give me 6 that add to give me positive 8? 1 and 6, no. 2 and 3, no. So it's not factorable anyways. And if you want to think about having to reduce, try one of these, two into there. Ooh, 3 goes into 6. 3 times 2 is 3 times 2, 8, or 3 plus 2, 8. No, then it's not going to work either. Even if it was factorable, maybe it's not factorable for reducing purposes. Okay, so that one's done. I can't do anything to that. I can't factor. I can't reduce. So we had 4. We had 1 we could reduce. But you always check. Always check. Questions? Okay, your turn. So, first thing we need to do, common denominator. What is in this first denominator that's not in the second? 3. So I multiply by 3 over 3, which gives me for my second fraction, I did that one backwards, I shouldn't have, 6a over 3ab. What is in the second fraction that's not in the first? b, so I multiply by b over b. So I get 5b over 3ab, which means I get 5b plus 6a over 3ab, and a and b cannot be z. We're going to be Canadian. If you want to switch to make it 6a plus 5b, you can, or you can leave it. I really honestly don't care. As long as you get the right terms, the right signs in front of them. Okay. The second one here, my common denominator is a little easier here. Once again, what's in the second denominator that's not the first? What's in the second one that's not the first? X minus 1. Good. You guys got that one good. X minus 1. X minus 1. So I multiply 2 times x minus 1. And I have x minus 1, x minus 3, minus what's in the second denominator? What's in the first denominator, not in the second? What do I need here? X minus 3. And so you get x cubed minus 3x squared over x minus 1, x minus 3. And what are our domain restrictions? X can't be 1 and 3. Change the subtraction to addition. Get negative x cubed minus 3x squared, or sorry, plus 3x squared, plus 2x minus 2 all over x minus 1, x minus 3. Yeah, it's not factorable. I wouldn't worry about it. I wouldn't worry about it. It might be, but from what I can try to do off the top of my head, I don't think it is. And if I need to go any further than this to try to figure out if x minus 1 is a factor, that involves synthetic division, and I ain't going to do that. Okay? So you guys finish up C and D. If you don't have those two done, thank you for your patience, by the way. You guys were awesome. You guys were really awesome. Not a lot of kids can do that well. So, factor your denominator. D squared plus 4D plus 4. D plus 2. D plus 2. Or you could think of it as D plus 2 squared. I like to, when I'm doing this, think of it as D plus 2 factors rather than 1 squared. It makes it a little easier to see what you need. So all I need to do is multiply the second one by D squared, or sorry, D plus 2. So I multiply this one by D plus 2 and D plus 2. The first fraction does not change. 3D plus 1 over D plus 2 times D plus 2 minus, and then I have to FOIL the second one out. Square the first term, add the two constants. Negative 1 plus 2 is 1, so that means I have 1D. Multiply the 2, negative 1 times 2 is negative 2. all over d plus 2, d plus 2. And once again, our domain restriction is d can't be negative 2. I have my common denominators, d plus 2 times d plus 2, that's my denominator. Change my addition, oh, and I forgot to square that, my subtraction to addition. So I have negative d squared, 3d minus d is plus 2d, 1 plus 2 is plus 3. And the question is, can I factor to cancel? Well, my only factors of 3 are 1 and 3. It might be factorable, but 1 and 3 are not going to cancel with 2. So even if I can factor it, there isn't going to be anything to cancel. I'm not going to bother trying. And to factor, what I would do is I would pull out a negative first, change all the signs, and then it is factorable. It would be d plus 1, negative 1 times d plus 1, d minus 3. But those wouldn't cancel anyway, so why bother? Okay. And what you want to do is you want to look at this last term. Is 2 a factor of 3? No. It's not factorable. Or it's not reducible, I should say. Next one, same idea. First step, factor. 2 things multiply, give me 5, they give me 6. 1 and 5. Okay. So I can't have what are my domain restrictions. X can't be what? Negative 1 and negative 5. That'll give me 0 in my denominator. What do I multiply the numerator by? What do I multiply the first fraction by? X plus 1 and then over x plus 1. X plus 1 over x plus 1, which gives me x plus 1 times x plus 5. And then when I multiply x minus 1 times x plus 1, I get x squared minus 1. Sum of difference. They're exactly the same except for plus and minus. Square the first minus the square of the second. If you FOIL it and combine like terms, the middle term will disappear anyways. Plus the second one doesn't change. X plus 3 all over x plus 1, x plus 5, and I guess I'm recording. Combine up like terms, x squared plus x, negative 1 plus 3 plus 2, all over x plus 1, x plus 5, and x squared plus x plus 2 is not factorable, so I'm done. You do always want to check, but it's not. There are no numbers that multiply to give me negative, that multiply to give me positive 2, that add to give me a positive 1. It's not factorable. So I'm done. Okay, questions on that? Not too bad, is it? You have to be careful. You have to be careful. You have to be meticulous. Your factoring skills are the most important skills you're going to have from here on out for this reason. You can't do this if you can't factor quadratics well. So you can kind of see what I said earlier when we were doing quadratics. You will need this later. You will need this later. You need this later. Okay? In fact, quadratics is one of those major skills you learn in Algebra 1. It's one of the big ones. You really use it a lot once you leave Algebra 1. It's one of those big ones you get. Okay? Example number 3, complex fractions. Okay. X plus 3 over 2 minus x over x minus 4. Okay? They're actually very easy to take care of. First thing I want to do, though, is I want to list my domain restrictions. I am not allowed to have 0 in any denominator. Not just here, but in this denominator as well. I'm not allowed to have 0 in any denominator. So, will 2, what will make 2 0? Nothing. There's nothing to do to 2. So it's but what about x minus 4? What makes x minus 4 0? Positive 4. So x cannot be positive 4. Yeah, if you want to see something really cool, as you're a kid growing up and you're learning how to do fractions, and you do invert and multiply. When you divide a fraction, what do? You invert and multiply. And I'm sure that some smart aleck kid in some class said, why? And I'm sure your elementary teacher said, because I said so. Or something along those lines, because they do not understand or do not want to explain why you invert and multiply. This is why you invert and multiply. I love doing these problems, particularly like this first one, to show inverting and multiplying. Okay? Because what do I actually have here? I have x plus 3 over 2 divided by 2 over x minus 4. That's really what I have, isn't it? Okay. So, in order to get rid of my complex fraction, and you don't have to do this on every step, but I want to show you this first step here. In order to get rid of my complex fraction, I want to make my denominator, my big denominator, 1. I want to make it a fraction over 1. So I want to get rid of my denominator, my big denominator, I want to make it 1. Because anything over 1 is just that anything, right? So what do I multiply 2 over x minus 4 to make 1? I multiply it by its reciprocal, x minus 4 over 2. And if I multiply the denominator by x minus 4 over 2, what do I need to do? Multiply the numerator by that. So what happens to my denominator? These cross cancel and I get 1. What did I do? I inverted and multiplied. This is where invert and multiply comes from. This is where that rule invert and multiply comes from. And you know why nobody explains it before you get to this part? Because none of you have enough experience in algebra and mathematics to understand this so you can get to compound fractions. It's very difficult to explain to somebody who's never seen a compound fraction why you invert and multiply. But now it makes sense, doesn't it? Now you understand why you did that. Because that's all we're doing. We're invert and multiply. Take the denominator, flip it over, and multiply. That's how you get rid of a compound fraction. So that means my answer is x plus 3 times x minus 4 all over 4. Because 2 times 2 is 4. And we're good. You do not need to FOIL it out. Oh, great rejoicing. Second one's a little goofier. I need to factor before I do anything else. And I can also simplify too. Okay? So my upper fraction, I can factor my denominator. This is 5 times, or 5 over m plus 2m minus 2. And squared minus 4, difference of 2 squares, right? And look what can I do here before I even do anything else? I have a 2 and I have a 4. Do you see what I did? I reduced the constants. And normally I wouldn't do that, any reducing, but they're just constants. Take care of that. Okay. What are my domain restrictions? What can m not be? Yeah, 2 and negative 2, plus or minus 2. Okay. So this is my original numerator. What do I need to do? I need to invert and multiply. Take the second fraction, flip it up, and multiply. Piece of cake, isn't it? Cross cancel. 5 times 2 is 10. 1 times m minus 2 is m minus 2. Questions? Okay. This one, just invert and multiply. What domain restrictions on this one are goofy? What's going to make my denominator 0? When x and y are the same. My domain restrictions on this one, x can't equal y. As long as x and y are not the same number, I won't get 0. If x and y are the same number, I get 0. So, but don't worry about it. That's not going to hit you on the test. Invert and multiply. X minus y over 8 and multiply. Ooh, this is easy, isn't it? X minus y is cancel. 2, 4, x over 4. Piece of cake. Right? Easy as cake. Piece of cake. Walking. Clear as mud. Questions? Okay, it's your turn. Just make sure you have plenty of time for your quiz, so it shouldn't be a problem. First thing I do, my domain restrictions, x cannot be 1. Okay, that's the only thing I need to worry about. Multiply by 5 over x minus 1, and I get 15 over x minus 1 squared, or x minus 1 times x minus 1. Either way is fine with me. Second one, I do need to factor. Y squared minus 1 is y plus 1 times y minus 1. So I can't have plus or minus 1. Y cannot be plus or minus 1 on this one. Okay. Once again, and I'm just going to slide the 4 over here, invert and multiply, y plus 1 over 3, and my y plus 1's cancel. So I get 4 over 3 times y minus 1. Easy peasy. Last one's a little harder. I do have to factor it out. 3s minus 1 is one of my factors. So 3s times s gives me s squared. So I get s, so I get s, so I have 3s minus 1. And then I have s to give me that. And then 1 times 3, and it's negative 1, so it's 3 there, so I get plus 3. And if I want to check to make sure this works, 3s times s, 3s squared, negative 1 times positive 3, negative 3. 3s times 3 is 9s, negative 1 times s is negative 1s. Combine those, I get 8. That's good. So this becomes that over s to the 4th. Okay. What am I not allowed to have? Right now, the only restriction I have is that s can't equal 0. That might change in my final answer, though. Okay? So I invert this and multiply. So I have 3s minus 1 over s times s to the 4th over 3s minus 1 times s plus 3. 3s minus 1's cancel. This s cancels with one of those s's, right? So I end up with s cubed over s plus 3. Couldn't have 0 in my original problem. Can't have negative 3 in my final answer. Remember, we have to check the original and the final answer as well. Okay? Any questions on this? Not bad. You guys seem to get the hang of it. We'll see what your quiz scores are like when you get tested.